Hello, hello, Jim Oskins here. Use case that I wanted to share with you today is about predictive analytics. And here's some of the algorithms that are included in Minitab. Cart's included with base Minitab. There's an add-on module for random forest, TreeNet, and other things. The use case I wanted to share with you is a fascinating example in agriculture. Thought it would apply to this little series of videos that I'm making for you. The customer, they wanted to prevent contamination in well water. The picture I'm showing there big on the screen on the right side is showing how fertilization along with irrigation and rainfall lead to some of the, we'll call them nutrients, some of the chemicals getting into the water supply. And even Google here, a simple Google search knows over application, just bad luck, poor timing, excessive irrigation, heavy rain. There are some known things of what caused this. It seems like if we have things that we know cause inappropriate levels of contaminants in well water, we should be able to model that and help prevent those things, right? So that's exactly the task that this customer had. And one conversation that I had with the customer said that they did 60,000 or so nitrate tests. They've got tons of data. They're trying to analyze it with R or freeware, and they're just really struggling. It would take them weeks or months to write code to do any analysis, and then it's just not as beautiful and easy as the way Minitab does it. So they looked into Minitab's predictive analytics, and what used to take months took minutes. So I'll show you how that works. Their end goal was actually to make a website running Minitab's model ops to deploy this model that they create off all their existing data. And they wanted to let customers put in like their county that they live in and other environmental factors around their situation. And the model would tell them like the risk of having excessive levels of nitrates, et cetera, in their water. Like I loved it. It was amazing, super useful. It made you feel good just to work on a project like that. Now, I can't show you the customer's data here on this video. However, I've got some of my own data sets that I got from minitab.com. You can download data sets there, and I'll just walk you through how predictive analytics works on these. I mean, some of these are kind of similar. Like here, if we just replace this pulp brightness data set with like nitrate amount, nitrates, we could pretend like it's similar to the customer's data set for this. I'll just run the automated machine learning for this continuous response, right? Column 9 there, the nitrates, it's a continuous response. Automated machine learning, please, Minitab. Look at all these predictors and tell me which of those influences nitrates. Now, just a disclaimer, as you get into this, you're going to have, especially these two buttons, you're going to learn so much as you go into data science. Like as you go down this journey with Minitab, you're going to see so many features and validation and options. But for now, I'm going to leave them as default. You can learn more about that with us later. I'll put some links in the section below so that you can see different options to learn more about this. All right, but here we go. So automated machine learning, it just ran all those algorithms that applied to this type of data and told us which one fit the best. Now, every data set, I'll explain this as I go through a few data sets with you. Every data set is capable of having different types of hidden signals and different algorithms like MARS, TreeNet, plain old school, classical linear regression, random forest and cart. They all are capable of finding different types of signals, better efficiency. So in this case, MARS won. It's got the highest R squared, just by a hair over my friend TreeNet, one of my favorite things. I love some of the graphics that come with TreeNet. I love Mars as well. If you don't like R squared, mean absolute deviation is another metric. But Mars is fascinating. Mars gives you an equation just like you're used to with plain old regression. The thing is, it breaks up the data sets to give you a different piece of an equation for different regions of the graph. Let me show you what the heck I mean. So if we have X versus Y here, and like there's no response for a while, change X, you don't get any change in Y, and then something happens, and then maybe it falls off a cliff again, I don't know. But if you have something like this, there's not a single equation that's going to fit that. Like if you have some monotonic expression that represents your entire data set, yeah, we could just draw a straight line through that, and that represents it very well. But here in situations like this, that would be terrible. That red line doesn't fit at all. So the way Mars works is it makes little basis functions. Like I said, something happens here where X equals, I don't know, whatever that is. And y is basically constant until we get there. But after that, we have some quadratic. And then something happens here. So we get y1, y2, y3 maybe y4. And that explains this data set, not just a single equation. So that's a huge advantage over Mars has over other regressions. But if you check this out, it says, all right, for this particular data set, it looks like the biggest influencer of nitrates is production rate. Maybe for this, mock-up I'm doing to represent the agriculture customers' data. Maybe we'll say that's rainfall rate. Okay, H2O2, caustic chemistry, unbleached, conductive. Those are all less important than the production rate or the rainfall rate here. Okay, so how exactly does that work? Well, here's production rate versus nitrates. Looks like it does have a flat region, then it goes up. Something freaky happens here. I'm not sure I would trust that 100%. I'd do a follow-up study. That's just my way of thinking. I'd always, with old observational data, I'd use it to guide me. But if it's my first analysis with it, I might do a follow-up study to figure this out. But I'm seeing the general trend here. No nitrates for a while until the rate hits a certain level. Then it goes up dramatically, and then maybe it even falls off. Maybe it dilutes it if the water goes up, if the rate goes up. Okay, so that's very interesting. I could use this to help me plan my next experiment. Like, I'd really want to focus on this area. I'd also want to know, is this legit? That if there's more water, then it really decreases nitrates. So I love that. This one's a little simpler. This is just a simple bend in the equation, right? Like, here's the bend point. We have a flatter slope here than a steeper slope here. Like, here's another one. This it's just very common to see these things in larger data sets of historical or observational data, happenstance data, as some of my old friends used to call it. Like, nothing matters. There's no impact on nitrates until this reaches a certain level, and then it falls off linearly. That happens. It's tough to model that with. I think how old school regression, even just drawing a straight line like we all learned in 6th grade or whatever, like a curved line would always be off right here. If you had a straight line, that would be just terrible. Right? So Mars helps a lot. Now, when you do automated machine learning, let's say Mars comes up as the winner, but like, I wonder what CART would have looked like. Like, CART's what, for a lot of you, CART is what you're using today because it's included in base Minitab. When you get the add-on module, you have all these extra features. So if you're like, you can click select an alternative, and if you want to see, I wonder what CART would look like, you could just make that real quick. Same data set. Look at this. It's saying, all right, for this top node that represents all the data, where the mean is 79 of this nitrate column here, the mean 79, a huge standard deviation. It says if production rate's less than 100, so it's not a graph like Mars had, but it says if it's less than 100, something happens. If it's more than 100, something different happens. Like, it looks like if the rate was over 100, the mean was much higher than when the rate was below 100, the mean is much lower. That's 80 something versus 70 something, big difference. You still get your relative variable importance chart, but notice in this one, CART, which was one of the worst fitting ones for this particular data set, notice this pattern, production rate, H2O2, caustic. Compare that to split view, please. Yeah, just a little different ratios of how important each variable is. In this case, they match up pretty close. I mean, at least you have the same order. Sometimes you'll see different variables in totally different places on this importance chart. Yeah, all right. So that's like a quick intro, somewhat similar to the customer's example. I just love the customer's example. I mean, again, I'll go back to the screen and then I'll show you a few more predictive analytics examples. Like, if you could find key indicators that help you see the risk, you can have just a quick idea of the risk of your well water being contaminated. A complex model, complex math, there's tons of details behind it. But I'd be happy if my governor put something out like this where I could see maybe before I bought a property, maybe before I invested in a well or an upgrade. It'd be super important. So utilizing Minitab's predictive analytics, they were able to understand the groundwater much better. For that data set, it ended up being random forest was the one that worked out the best. Very low, just so I don't scare you off here, very, very few areas in this state that we were looking at had any well water contamination. It's a very small percentage. It's just the severity is high enough that they wanted to model this, and they got funding to look at these things. So I don't remember, maybe it was like 1% of the wells tested had nitrate contamination. I don't remember, but it was a fascinating use case. All right, so back to Minitab to show you, like if you wanted to see what some more of these data sets would look like, let me show you some. Here's a different data set, totally unrelated, but we have a categorical response in this one. Like if we'd like to know what the heck drive thing is out of spec, like there's very few out of specs here, but if we'd like to know, please Minitab, help me figure out if any of these predictors influence things going out of spec. You could do that same thing. You could do automated machine learning and it'll run them all, or you could pick your favorite. You know, if I just want to see TreeNet, like please, for the target here, help me figure out what is driving out of spec. I think it could be these continuous predictors. I think it could also just, I'd love to blame the dye manufacturer or the site where we're testing this. Hit OK. And real quick, it tells you temperature is the most important, line speed, diameter, secondary. Don't blame the manufacturer. They're the least important of these predictors. There's so much detail here. You can learn more about this if you take any of our classes. Or yeah, here's a really interesting graphic. Like, how does temperature matter exactly? Well, it looks flat until it hits a certain temperature, somewhere around 60, and then it falls off dramatically. This one, if you're familiar with working with classification type of data sets, we don't just have the metric plotted here, right? The metric is just in spec, out of spec. So what we're doing is converting that, in this case, to fitted half-log odds for target. Okay, like what are the odds of being in spec or out of spec is what this graph is kind of saying. Yeah, I love the graphs. Just, all right, if I did want to look at site, looks like Vancouver has a much lower fitted half-log odds for out of spec than Baltimore does. We might want to go check that out. What's the difference between those? Go to another data set. A lot of people use this for survey analysis. I've got a net promoter score here. This is a little more complicated, a few more columns here. I mean, predictive analytics can handle thousands or millions of rows and past 4,000 predictors. I haven't had a customer come to me yet say they needed more than 4,000 predictors, 4,000 columns in here. So it can handle really big data sets. This one is 5,000 or so. So if we wanted to know like what influences net promoter score, you could just go right back to that same thing, do automated machine learning, let it run all of them, or pick the one you want to see. You know, if you love Mars, use that. If you want to try random forest, split this data set up, make a bunch of different models. So I hope you get the gist. Minitab's predictive analytics. I gave you a quick walkthrough. CART, random forest, TreeNet. If you want to know more about that, we've got training options, predictive analytics. Yeah, here's a nice set. If you wanted to go deeper than this super simple high-level overview I've done for you today, machine learning class would show you all that stuff I showed you in much better detail. Advanced machine learning would go into a lot more. And you'd probably be smart if you took the prerequisites. Fundamentals of analytics, it's going to just show you about how to use basic Minitab, regression modeling and forecasting. I mean, I showed you a regression model that's super complicated with Mars, multi-adaptive regression spline. So regression primer is probably pretty useful. But machine learning is the class of interest, and then the advanced version of that really gets into some of the details behind those validation and options buttons. We have a condensed version in our education hub. I'll give you a picture of that real quick. Yeah, so education hub, similar classes here, a lot of my favorites that I used in my career. And then predictive analytics, you can see those same kind of prereqs, correlation regression, multiple regression, and then the predictive analytics, where you'd learn a lot about CART and Mars and TreeNet and random forest. If you want to know any more, give me a holler. Nice chatting with you today.